Hello students. In the previous session of chapter 7 coordinate geometry, we have discussed about section formula, internal division, and today we are going to discuss about section formula, external division. Means the point C will divide the line segment AB from outside. This point will not lie on the line segment AB. Now, since we have used section formula for internal division, so section formula can also be used to find the coordinate of a point that lie outside the line, where the ratio of the length of a point from both the line segments are in the ratio m:n. So the section formula is given by mx2 minus nx1 upon m minus n and my2 minus ny1 upon m minus n. As you can see, this is a point A, this is point B and this is point C. We need to find out the coordinates of point C, and A is x1 y1, B is x2 y2, which is divided by the point C in the ratio m:n. It is very easy to remember this formula as we have used for internal division the formula as m x2 plus n x1 upon m plus n. Simply replace this positive sign by this negative sign. You will get the coordinate of x, and for y also you have to replace the positive sign with the negative sign. You will get the formula for external division. Now to derive the internal section, we took a line segment and a point CXY inside the line. But in the case of external section formula, what we need to do? We have to take that point C outside the line segment. As you can see the diagram, we have taken point A, x1, y1, point B, x2, y2. So this is a line segment. Here we have taken a point C, x, y, which is dividing this line segment in the ratio m:n. So let A x1 y1, B x2 y2 be the endpoints of the given line segment AB, and C x y be the point which divides AB in the ratio m:n externally. Now we need to find the coordinate x, y of C. For that, we have to draw perpendiculars from A, B and C parallel to y coordinate joining P, Q and R on x-axis. As you can see, AP, PQ and CR. Now we have to calculate the values of AM, BN, CM and CN. Now how you will calculate it? Now see AM. This is parallel to PR. So the value will be OR minus OP. OR minus OP will give you the value of AM, or you can say PR. Now here OR is what? X. This total is X and this is X1. So X minus X1 will be the value of AM. For BN, I can say this is equal to QR because both are parallel. How you will calculate the value of QR? OR minus OQ. Consider OR minus OQ. Now what is OR? This total is X and OQ is X2. So X minus X2. How you will calculate CM? This is how you will calculate this. CR minus MR. This will be Y minus Y1. Similarly, you can calculate Cn, which will give you Y minus Y2. Now, this angle and this angle both are equal because both are corresponding angles. This angle and this angle both are equal because both are of 90 degree. So, by AA similarity criteria, triangle AMC and BNC both are similar. Now, if the triangles are similar, we can write the sides in the ratio as AC upon BC, AM upon BN and CM upon CN. Now, we have the values with us. Simply substitute the values of AM, BN, CM, CN and you know AC and BC are MN. So, M upon N will give you after substituting the value of AM, as you know, AM is x minus x1, BN is x minus x2, CM is y minus y1 and CN is y minus y2. So, you can simply calculate, you can write this as both are equal and these two are equal. So, M upon N is equal to x minus x1 upon x minus x2 and M upon N is equal to y minus y1 upon y minus y2. Now, we need to calculate the value of x and y. For this, we have to consider first M upon N, x minus x1 upon x minus x2. Now, cross multiply. What will you get? M x minus x2 is equal to N x minus x1. Solve for x. You will get x as M x2 minus N x1 upon M minus N. And now for y coordinate, what will you do? You have to consider this. M upon N is equal to y minus y1 upon y minus y2. Solve for y. What will you get? M y2 minus N y1 upon M minus N. So, the section formula for external division, the coordinates of C will be Cxy are M x2 minus N x1 upon M minus N and y2 minus N y1 upon M minus N. Now, what will happen if we change the ratio M is to N to M1 is to M2? Means the coordinates of the point, suppose A, x, y, which divides the line segment joining the point P, x1, y1, P, x1, y1, Q, x2, y2. Externally in the ratio M1 is to M2 means there is a point which lie outside which is A, x, y and it divides the line segment PQ in the ratio M1 is to M2. So, what will happen? The section formula will become M1 x2 minus M2 x1 upon M1 minus M2, M1 y2 minus M2 y1 upon M1 minus M2. Now, what will happen if the ratio becomes k is to 1? You have to simply replace M1 by k and M2 by 1. You will get this formula as kx2 minus x1 upon k minus 1 and ky2 minus y1 upon k minus 1. So, this will be the section formula if the ratio becomes k is to 1. Now, we will understand it with the help of an example. A 4, 5, B 7, minus 1 are two given points and the point C divides the line segment AB externally in the ratio 4 is to 3. We need to find out the coordinates of C. So, we have considered a line segment AB whose points are 4, 5, 7, minus 1 we need to find out the coordinates of point C, which I have taken as x, y. Now it is dividing the line segment externally in the ratio 4:3. So here m is 4, n is 3. This point will be A, x1, y1, and this point will be B, x2, y2. So the value of x1 will be 4, y1 will be 5, x2 will be 7, y2 will be -1, m will be 4 and n will be 3. So the section formula we have to use is mx2 minus nx1 upon m minus n, my2 minus ny1 upon m minus n. Simply substitute the values of x1, y1, x2, y2, m and n. So what will you get? Here the x coordinate will be mx2 minus nx1 upon m minus n. Substitute the values, you will get the value of x as 16. For y, what you have to do? You have to consider this. So my2 minus ny1 upon m minus n. Simply substitute the values and you will get the value of y as minus 19. So the coordinate C will be 16 minus 19. Now let's take up a special case. What if the point M, which divides the line segment joining points P, x1, y1 and Q, x2, y2 is midpoint of line segment PQ? Means what? I have a line segment P, x1, y1, Q, x2, y2 and I have a point M on the line segment which is dividing this line segment into two equal parts. Since midpoint divides the line segment into two equal parts, so what will happen? This will divide it in the ratio 1:1. So if M is the midpoint, then M divides the line segment PQ in the ratio 1:1. So M and N both are 1. Now we have done the section formula for internal division, which was M x2 plus n x1 upon m plus n. So simply replace m and n by 1. What will you get? 1 into x2 plus 1 into x1 upon 1 plus 1. And for y also, what we have? M y2 plus n y1 upon m plus n. Now simply replace m and n by 1. What will you get? 1 into y2 plus 1 into y1 upon 1 plus 1. So therefore coordinates of a point which is the midpoint of line segment joining points P, x1, y1, Q, x2, y2 are x2 plus x1 upon 2 and y2 plus y1 upon 2. Now let's understand it with the help of an example. The vertices, 4 vertices of a parallelogram are A -2, 3, B 3, -1, C, P, Q and D -1, 9. Find the value of P and Q. Now since we have a parallelogram A, B, C, D whose vertices are given, A as -2, 3, B as 3, -1, C as P, Q and D as -1, 9. We need to find out the value of P and Q. Now as you know, the diagonals of a parallelogram bisect each other. So what are the diagonals over here? AC and BD. So let O be the point, this is O. So O be the point at which the diagonals intersects. Both the diagonals are intersecting at point O. So the coordinates of midpoint of AC and BD will be same. This is BD. Its midpoint is this. And this is AC, whose midpoint is this. So both are intersecting at O. So now what will happen? By using the midpoint section formula on AC and BD, we have to calculate the values. So since we are first using the midpoint section formula on AC, we have x2 plus x1 upon 2, y2 plus y1 upon 2. So this is AC. You can consider this point as A, x1, y1, and this point as C, x2, y2. Simply replace the values of x1 by -2, y1 by 3, x2 by p, and y2 by q in this formula. So what will you get? -2 plus p divided by 2, q plus 3 divided by 2. Now on the side dB, this side, again consider this as x3, y3, and this as x4, y4. You can write this as x3 plus x4 divided by 2 and y3 plus y4 divided by 2. Or you can again use this as x1, y1 on x2, y2 by simply replacing like this. So substitute the values of x3 as -1, y3 as 9, x4 as 3 and y4 as -1. What will you get? -1 plus 3 divided by 2, 9 minus 1 divided by 2. The coordinates will be 1, 4. Now consider this equation and this equation. This is x coordinate. This is also x coordinate. So both will be equal. So -2 plus p divided by 2 is equal to 1. Solving for p, you will get p as 4. For q, q plus 3 divided by 2 is equal to 4. So solving for q, you will get q as 5. So the coordinates of point C you can easily find out, means you can find out the value of p and q. Now exercise 7.2, question number 7. Find the coordinates of point A, where AB is the diameter of a circle whose center is 2, -3 and B is 1, 4. So we have a circle, diameter AB, and we have the coordinates of center as 2, -3 and B as 1, 4. We need to find out the coordinates of point A. So let the coordinates of point A be x, y. Now midpoint of AB is given as 2 minus 3, which is the center of the circle, and coordinate of B are given as 1, 4. So 2 minus 3 is equal to, by using the midpoint section formula, x plus 1 divided by 2 and y plus 4 divided by 2. Now simply take the x coordinates. X plus 1 divided by 2 is equal to 2, and by taking the y coordinates, y plus 4 divided by 2 is equal to -3. Solve for x. You will get x as 3 and y as -10. So the coordinates of point A are 3, -10. Now this is your home assignment. First one, if 1, 2, 4, y, x, 6 and 3, 5 are the vertices of a parallelogram, taken in order, find x and y. Second, if a and b are -2, -2 and 2, -4 respectively, find the coordinates of P such that AP is equal to 3/7 of AB and P lies on the line segment AB. Third, line 2x plus y minus 4 is equal to 0 divides the line segment joining the points A 2 -2 and B 3 7. Find the ratio of line segment in which the line is dividing. Now just quickly recapitulate what we have done today. When the point which divides the line segment is divided externally in the ratio m:n lies outside the line segment, that is, when we extend the line, it coincides with the point, then we can use this formula which is called section formula, which divides the line segment externally in the ratio m:n. It is also called external division. If the coordinates of A and B, we have taken the coordinates of point A as x1, y1 and B as x2, y2. Then the external section formula is given as m x2 and x1 divided by m minus n and m y2 and y1 divided by m minus n. I hope you have understood the section formula external division very well. Thank you.